To determine the base table, GeneXus will extract the attributes referred to in the for each. Then it finds the tables where they're located and takes the base table whose extended table contains them. What will happen if we add, in the for each, an attribute of attraction, such as attraction name, for example, within the print block? Now the tables involved are attraction, country city, and country. So the base table will now be attraction. And what does this mean? That the listing will not contain countries, but rather tourist attractions. And the country and city listed in each case will be those of the attraction and not those of the country-city table. So, when we execute, we can see the listing that results, where the navigation listing tells us that the base table is attraction and that it'll be gone through in an order based on attraction ID, primary key, going through the whole table. And accessing to country to recover country name, the country of the attraction, as well as to country city to recover city name, provided city ID has a value, since we had specified the possibility of leaving the value of that attribute as null. We would obtain the same base table, attraction, if instead of adding the attraction name attribute to the print block, we added it, for example, in the order clause. Now we require that it go over the base table of the for each, sorted by attraction name. Again, in order to determine the base table, GeneXus will extract all the attributes of the for each, including those of the order and where clauses, if any, etc. Let's see the navigation listing and the listing that results. The base table is attraction. It'll sort by attraction name, and for each record, it will access the country table through the value of the foreign key, country ID, to recover the value of country name. The same will happen in the case of country city to recover the value of city name. In the PDF, we can now see that only the country and the city of each attraction are printed. To verify this, we can add the name of the attraction in the listing. The navigation listing also informs us that there is no index in the database by the attribute by which we need to sort the information. So our performance could be low for this query. Why? Let's suppose the attraction table with the following data. If we need to obtain its records sorted by the attribute attraction name, then it'll have to be reordered by this attribute in some way. However, this could take too long if millions of records are involved. The existence of an index at the physical table level would optimize the query. We should recall that indices are efficient ways to access data, just like dictionaries that index by a specific attribute or set of attributes. In this case, 1, attraction name. The disadvantage in creating an index is that, from there on, it has to be maintained. So when an attraction is added, such as the Sao Paulo obelisk, then the index must be reorganized. Creating an index for a table in the database is simple and may be done at any time. We find the table, open it, and go to the section that includes information about the indices defined. These 3 indices are the ones automatically created by GeneXus from the keys, primary and foreign, to make referential integrity controls efficient. Let's create a user index. When we press enter, we get this default name, which we can change as we please. Our index consists of the attraction name attribute sorted in ascending order. If attraction names cannot be duplicated, We must control this by indicating that the index must be unique and not duplicate. In such cases, an automatic control will be done every time that an attraction is entered so that there is no other attraction with the same name. In our case, repetition will be possible. We should think that, for example, it's common to find an obelisk in every country, so we leave that value as duplicate. Having done this, when we press F5, the database should be reorganized to create that new index. We should remember that the report's navigation listing told us that we had no index to satisfy the query. Now we'll see what it tells us after the reorganization takes place. It tells us that it will use the newly created index. We can delete it anytime, just as easily as we created it. F5. Reorganize. And the navigation listing will inform us again that there is no index to satisfy that order. Database manager systems often store statistics of data and accesses, which provide them with some intelligence to select the best access plan based on the attributes that are part of the query. To see this aspect in detail, based on the generator used, we recommend you do a search in our documents. In this case, it'll be enough to know that if we specify an order and there is no index created, then a temporary index will be created to be used for the query, and it'll be discarded afterwards. Or the DBMS will solve this with some other strategy. So, what must we do to request a descending order? We just put the attribute inside the parentheses.